What's up? Welcome to Backend Stuff. I'm Jacob Blitzo, here to help you build tech for the future. Think about scalability, reliability, and cost. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. This is episode 5 in Elixir Basics. Today is all about lists. We will be learning about linked lists, how to create them using the literal form, head-tail notation, and how to properly append values into a list. Let's jump right in and start writing some code. Lists are a basic data type in Elixir for holding a collection of values. Lists are immutable, meaning they can't be modified. So any operation that changes a list actually returns a new list. Lists implement the enumerable protocol, which allows them to use the enum and stream module functions. Lists are implemented as linked lists in Elixir, not as arrays. And a linked list is a sequence of nodes. Let me just get my pen up and So a linked list is a sequence of nodes that contain two fields. The first field is an integer value. So we have this two fields, right? Split. And you'll have some integer value here that would reference either a string character or an integer or any value that is in the list, right? So we'll just put a number there, 99. And then the second field is a link to the next node. So this field links to the next node. So then we have another node here with two fields and another value and another node linking to another node. And it goes on and on and on. And then at the end of the list, they have what's called a terminator. And that is just a single field so you know that it is the end of the list. So this means accessing an element in the list takes linear time depending on the length of the list. So the longer the list, the longer it takes to iterate through that list. Let's jump right in and start writing some code, and we can walk through this stuff right away. So command space, and let's open up our terminal. And as always, I will make this bigger for us so you can read it easier. And let's cd to the desktop and mix new linked underscore lists is what I'll call this project. You guys can call it anything you want. And let's go ahead and cd into this project linked lists. And let's go ahead and get right into the Elixir shell, i.e. x space dash capital S space mix. A list in its literal form is just a opening square bracket and a closing square bracket. Enter. That is an empty list. So if we wanted a value in it, we could do this opening square bracket 1, closing square bracket. And now we have a list with a single value in it, okay? And we can do this, we can add more values separated by a comma. So 1 comma, 2 comma, 3 comma, closing square brace, enter. And now we have a list with 3 elements in it. That's pretty cool, right? And we can also take a element, we can do an element of 1, and we can do a plus plus and combine it with an element of 2 and hit enter. And now we have one list with 1, 2, 3. So we took one list with just the element 1 in it and a second list with the elements 2 and 3, and we combined them. And now we have one list with 1, 2, and 3. We can also jump into the head-tail notation. The head-tail notation uses the cons operator, also known as the pipe key on the keyboard. You can do things like this to append lists, right? So we can do 1, and then you can do the cons operator, and then let's put another opening square bracket, 2, comma, 3, closing square bracket, and one more closing square bracket. So this is basically prepending 1 to the list 2 and 3. And prepending means it's putting it in the first slot, not the last. So when I say append, it means we're putting the value at the end of the list. Prepend means we're putting the value at the beginning of the list. I want to explain this a little better. I feel like we jumped right into head-tail notation. So I'm going to just pull up my little drawing utensil here. With head-tail notation, you have the head, and then you have the con operator, and then you have your tail. We could have a list that is like 1, 2, 3, right? Super easy. Okay, so value 1 here is the head. And then the tail is the rest of the list. When you think of head-tail notation, when you separate it with the pipe key or the cons operator, you're separating the head from the tail. And you can have multiple values in a head, just like the tail is assumed everything that you don't define. So as we jump in, let's make a list. So list equals opening square bracket. Let's do 1, 2, 3, 4, 5, 6. Okay, closing square bracket. Just hit enter. And now if I type in list, it's just saved. That list is saved. And if I were to do opening square bracket, type first, comma, second, and then the cons operator, and say the rest, closing square bracket. And now we can say this is equal to list. All right. What this does is it's going to go down the list from the index 0 and up, right? So as many variables that I put in front of the cons operator, they'll get assigned in order. And then everything after the cons operator is the tail. It's the rest of the list. So when I hit enter here, I can just go ahead and type first now, and it will return 1. I can type second, and it's going to return 2. And now when I type rest, it's going to return a list of 3 through 6. So that's the rest of the list. And that is the head-tail notation. And we'll jump a little more into it as we open our project up. And then another thing to know about lists is they can be any data type and a mix of different types as well. So we could do something silly like we could put a 1 in there. We could put an atom value in there. We could put a float number in there. And then let's go ahead and just throw a literal string, closing square brace, and hit enter. And that is a list, and it's okay to mix values. I'm going to just go ahead and Control CC twice to get out of the mix shell. And let's pull up Visual Studio Code. So file, open folder, and I'll pull this project over here. And now expand our lib directory and go into our LinkedLists.ex file. And we'll delete our hello world function. We do not need it. Let's do something a little fun with this. Let's make a list for Blork. Blork needs his equipment list so he can keep track of everything that he has. And just for simplicity's sake, let's make a function that just returns an array so we don't have to keep writing the values over and over. So let's do def get underscore equipment underscore list, opening and closing parentheses, space, do, and then return, and the end is added for us to close off the function. And now just to return a list for us, opening square bracket, and then let's do a double quote. And let's see, the first thing that Blork needs in his equipment list is a space helmet. All right, closing quotation. It's going to be a list of strings, and then comma, space, and then let's also do a spacesuit. Closing quotation, comma, and he needs his snacks, comma, probably a grappling hook, Who knows when you'll run into needing a grappling hook. And lastly, a probe. All right, and then closing square brace. And now we have our function that will always return this list of strings for us to transform and learn, list module functions, enum functions, and all that fun stuff. I think the very first thing we need to do is probably write a function that gets the first item from the list, right? Makes sense to me, right? So let's do def get first item, separated with underscores, opening parentheses, and the argument is going to be list. Closing parentheses, do, and then end to close off the function. The kernel has some built-in functions that we have straight access to for collections. Remember when we just learned about the head, tail? Head is the first item, right? So they have this cool function called HD. And you can see right here that it returns the head of a list. So we can do HD, opening parentheses, pass in the list. And then closing parentheses, let's save it. Let's go into our terminal again. And I don't know why I quit out of our shell. Let's go back into our shell, IEX space dash capital S mix. And that compiles our project for us. And now let's go ahead and do LinkedLists dot. You know what? Let's first save our list. We just have to call the get equipment list. So let's do list equals LinkedLists dot get equipment list. Enter. So we have our equipment list now saved to a variable called list. And now we can do linked lists. Linked, it helps to spell. And then we're going to say get first item and pass in our list. So before I hit enter, our first item should be our space helmet at index 0, right? So hit enter, boom, we got the first item in Blork's equipment bag, and that is his space helmet. With that being said, how do we use tail? All right, so if we wrote a function that was just called, I don't know, since the tail would be the rest of the list, right? We could do something like def remove first item, and then pass in a list, opening, closing parentheses, do, end. The kernel also has a function for collections, and that is called TL, and this returns the tail of a list. So if we pass in the list, closing parentheses, save it, and if we were to go back into our Elixir shell and do a recompile, since we changed the code, if we do linked lists dot remove first item and pass in our list, it's just taking the tail and not the head of the list. So we should get everything except for space helmet at index 0. So hit enter, and there we go. We have a list with one less item in it. Spacesuit, no space helmet. But don't worry, if I were to type our variable we saved list right now, it was never manipulated because it's immutable, and we actually didn't reset that variable. So we just let the remove first item transform our list, which we just asked for the tail of the list back. All right, moving forward. All right, so I think another important thing for Blork to do would be adding things to his equipment bag, right? So let's go ahead and do def add, and we will pass in the new value he wants to add. Well, we'll pass in the list first, and then the new value he wants to add to the list. Okay, so do end. So commonly, like when you add something, it should just go to the back of the line, right? So we're going to append the list. Elixir makes this really easy. We can do list plus plus value. One thing we have to do here is we have to put the value, since we're just passing in a string, we have to put the value we're adding in a list because it's appending one list with another list. All right. And then it's just combining the two of them. All right. So let's save this and let's go back to our shell, recompile. And now if we do linked list dot add, we pass in the list and then, oh, I don't know. What should we add? Like what else does Blork need? He's got snacks. Let's go. He probably needs boots. All right. So opening parentheses, boots, closing parentheses, and then, I meant double quotation marks. You got the drift. You're watching me type. All right, then closing parentheses and hit enter. And now look at that. Our list has a new item added to it. Now, one thing though, if I were to type in list, it's not added. So with that being said, let's go back up and our linked list.add. We want our boots to be saved to our list that we created. So list equals this. And now we're going to create a new list and save over the old list. Hit enter. And now if we do list, you see our boots. All right. But we have a problem. When we go and look at our code, when you're adding items to a list, you have to iterate over the entire list. And with a linked list, this hits an anti-pattern problem. It requires us to walk through the entire list, adding the element at the very end for every iteration. So imagine if we were like mapping through this or using a recursive call and adding multiple items. Every time we add a new item, we're going through every single node until we hit the end and then adding the new value. So it's very slow, and the longer the list gets, the longer it takes. A way to correct that is prepending. We always know a list starts at 0 and it's really easy to add it to the beginning. But you're like, well, what if I don't want the new item at the beginning of the list? I want it at the end of the list. No problem, because we can reverse the list, prepend it, and then reverse the list again. And we can do that with a function from the Enum module. So let's rename this one add slow. It's bad. We don't want to do this one. Let's make a new one called def add fast. We want to use this one. All right, we're going to pass in a list and the new value, closing parentheses, do, and end. All right, so let's create a variable, list reversed equals. All right, and now enum, the enum module, dot reverse takes one collection, okay, and we're going to put in our list. All right, so the list we passed in, boom. So now we have a variable called list reversed, and we just passed in our equipment list and reversed it, okay? In fact, let's show it to you. Let's do list reversed. Let's just return that value, save it, go back to the terminal. Okay, struggling here. All right, let's recompile. No, that's okay. It's telling us that the value that we're passing in as an argument is not being used. So we'll get there. The compiler can yell at us for now. But now if I do linked lists dot add fast, and we're going to pass in our list and our value, just do an empty string for now, and then closing parentheses. So I'm passing in space helmet, space suit, all these items, and they should come back reversed. So boots, probe, grappling hook. I didn't realize that I had an extra O in there, but it still works. So it should all be reversed when I hit enter. And then boom, there we go. Boots, probe. So we know this function works the way we want it to. Let's go back to our code now. And what should we do with this code? We basically want to prepend this with the value that we're passing in, right? So if we let's make a new variable, new list, new underscore list equals, and with the cons operator, we can prepend a list. We already did this, right? So let's do a opening square bracket, our value, right? And then the cons operator and list reversed. Boom. Whoop. And then closing square bracket. So now we took our reverse list. We're adding a new value to the beginning. So index is 0, but we want our list back in order because it could be in order of priority or importance, right? So now let's just reverse our reversed list. So enum dot reverse and pass in our list, or I'm sorry, the new list, closing parentheses, save it, and let's go back to the terminal. Let's do a recompile. I want to save over our list again. So let's do list equals linked lists dot add fast. We want to pass in our list, which is space helmet, spacesuit, snacks, grappling hook, probe, and boots. And we have to pass in a new item. And I don't know, let's do, Blark needs a frickin' jetpack. So let's pass in a jetpack. So opening or double quotations, jetpack, double quotations, closing parentheses. When we hit enter, this should be at the end of the list because we reversed it. We prepended it at index 0 and reversed it again. Boom. And there we go. Look, we have our jetpack at the end of that list. And I hope you're already thinking from seeing previous episodes like, Jacob, why aren't we using the pipe operator? That's because I want you guys as a challenge to clean that function up and add pipe operators, because there's no reason we need 1, 2, 3 different variables. We should just have one value transformed all the way through, and the right value should be spit out. So I want you guys to take the add fast, and your challenge is to add pipe operators. A little hint, you might want to make a prepend function that takes the list as the first argument. That's all I'm saying, because I think you guys can do it. You guys already know this stuff. All right, one more thing. Let's see. We might want to remove an item, right? It's a little weird. Blark's carrying around a probe. So I think we should have the ability to remove something from his equipment bag. So let's do a def remove underscore item. And we're going to need, let's see, a list and the index value that we want to remove. And then do a do for opening, and then an end to close off the function. And the list module has a great built-in delete at tool. So we can simply do list.delete at, and you pass in our list and our index. And then it will remove an item at the index you ask. So let's save it, go back to our shell here and do a recompile. And then let's do linked lists dot remove item, pass in our list, and I want to remove our probe. So we have our space helmet 0, space suit index 1, snacks index 2, grappling hook index 3. All right, probe is index 4. So let's pass in index 4, close off those parentheses, hit enter, and no more probe. Whatever planet Blark is visiting, they are safe. All right, that's cool, right? One more thing though, like, what if Blark needs to know how many items are in his equipment bag? That's important, right? So let's just go ahead and do def and then equipment underscore count, pass in a list, do, and then end to close off the function. And kernel has a built-in function for this as well, and it's just called length. And we pass in a collection, so we're passing in our list. So pass in list. All right, so save it, go back to our terminal, recompile, and then let's do linked lists dot equipment count, pass in our list. And now it's going to, we didn't save over our list, so our probe is still going to be included. So it should return, let's see, 1, 2, 3, 4, 5, 6, 7 should be our equipment count. And then there we go. Boom. 7 items. Sweet. All right. There's one more thing before I'm letting you go. I think we should be able to verify an item is in our equipment bag. That seems important to me. Def check underscore for underscore item. And then you pass in the list we're looking that we want to search through. And then the item we're looking for. Close off the parentheses, do, and then end. The kernel has an awesome built-in function for this too. All we have to do is say item in list, and it returns a Boolean. So false or true. So save it. Let's go back to our terminal, recompile, and then so if we say linked lists dot check for items, and we pass in our list, comma, and let's say we want to look for our boots. So boots, double quotes, closing parentheses, it should return a Boolean of true. Oh, it said false, and I panicked for a little bit, like, what did I screw up on camera? I put boot. So there you saw, when it doesn't match, it returns false. Now it's plural, make it plural, and now it's true. We have our boots. So that's pretty cool. Back to what you guys are going to do for me. You guys, I want to clean up this add fast function. I want you to make it clean it up with pipe operators. And then, like always, let's add some documentation to all these functions, and let's create tests for them. So if you went into the tests directory, let's create a directory for this test. You can use the linked lists test right there. And let's write a test for all these functions so we always get what we expect. And like always, if you want to learn how to build scalable production ready APIs, hit that subscribe button. Follow me on my Elixir REST API building journey. Join my Discord channel. The link is in the description if you have any questions. If you need solutions, check out that GitHub link in the description as well. And all the solutions are there with documentation and tests written. See you guys next time.